Hello everyone, welcome everyone, welcome to today's movie. In today's movie we're going to take the chi-squared probability distribution and we're going to calculate some probabilities based upon that distribution, and we're going to use both Excel and SPSS. So if we look at Excel first, so what we have here is we have a chi-squared test statistic which is 1.86. We have the degrees of freedom as 8, and we wish to know what is the probability that the chi-square variable value is less than or equal to 1.86. So what we want to do is we can use the Excel function chi-squared.dist to calculate that value. So you need to know x, which is 1.86. You need to know the degrees of freedom, which is 8. And because you want the probability value of the area, then the cumulative is true. So the value of this area, which is quite small, is 0.01499 or 1.5%, which is quite small. Now, if you know, say for example, if you know this area here is 0.04, then you can use the chi-squared.inv.rt function to calculate what the value of the chi-squared variable x is equal to. And now what I've done here is I've just said the area is 0.4, the degrees of freedom is 10, and we use the chi-squared.inv.rt function. So if I click on there, you'll see that it's the probability of 0.04, then it's C8, which is the degrees of freedom. Now I've changed the degrees of freedom, please remember. Okay, and the value of the chi-squared variable value, x, is 19.02 to 2 decimal places. And I've included the second method using the chi-squared.inv function, as you can see on the screen. Now we can quite easily solve this problem using SPSS as well. So if I go to SPSS, you can see I've got the solutions there. So all I need to do is transform compute variable. So I'm going to go example 11a, and in the numerical expression, then what I want is the cumulative density function, but this time I want chi-square. So I want CDF chi-square. CDF chi-square, CDF, there we are. I found it. Okay, and then we want the quant number, which is 1.86, and the degrees of freedom in this case was 8. We click OK. I'll overwrite the current variable value. You see you get exactly the same number. Then the second example, transform compute variable, but this time I want to be example 11b. So what we do now is, because I want to know the value of x given the probable area, then I need the inverse function. So if I just reset that, and in there I'll put example 11b, doesn't like spaces. So I want the inverse function. There we are. And I want the inverse function for chi-square, which is there. So this time I want to know what the probability is. Now please note the probability goes from chi-square x equal to 0 all the way up to infinity. So this area is 1 minus 0.04, and then degrees of freedom was equal to 10. Oops, sorry, mistake, 10. Okay, and then click OK, overwrite, and we should get the same as before, 19.02. If I just do a screenshot, give me 1 second, and I'll transfer it over to the Excel solution and copy it into there. Oops, need to copy it across. Give me 1 second. There we are. So I'll just make it a bit bigger for you so you can see. Can you see there? Look. So this is the probability that the chi-square value is less than or equal to 1.86 if it is randomly selected from a chi-square distribution with 8 degrees of freedom. Okay, so you get exactly the same answers. Okay, and this here is what's the value of the chi-squared variable if you randomly select from a chi-square distribution with 10 degrees of freedom. And the area on the right side, this side, is 0.04, which means that this area is 1 minus 0.04, and that comes out to give you x, the chi-squared value, the value on this axis, as 19.02. Exactly the same values. Okay, so it's very easy to use Excel. It's very easy to use SPSS to do these simple probability calculations. Okay, that's the end for today. Take care.